Assalamu alaikum. This is Imran Khan once again, and I'm gonna explain about the diffraction. I will cover the complete diffraction part in this video, and this was asked to me by Imtisal. This is one of my students from India. Okay, so we're gonna start now. So before I start diffraction, I will just define and I will differentiate what is interference and what is diffraction so that you can understand better. Okay, so what is diffraction? You have completed interference in your syllabus. Maybe if you don't have completed, then I will tell you a little about the interference and what is the diffraction. Then we will see. Then you can understand better. So uh, interference, when it happens, interference when two light waves comes and joins together, and there will be the superposition of the waves, then we can call there is interference. Okay, and after taking the interference, we will get one interference pattern on the screen. For example, these two waves coming joining together here at some point. Okay, and we are getting the interference pattern. If you are going to see here what is looking from this side, so it will be like this, something like this. Okay, so what is the diffraction? Okay, to explain this, just I will start with this. This is the this is the result of two different sources of light. Interference is the result of two different sources light. Okay, here diffraction, we don't need two different sources to produce the diffraction. We need only one source. Okay, for example, here I have the source. I'm just showing you the picture, just showing you the phenomena. Let you understand the basic, then you can understand full. Okay, let you clarify your concept. So if this is a source, okay, only one source, and I put some slit here. Okay, so what will happen? It is ordinary source, so light will move in all possible directions. So it will move like this, and this is a slit. It is an obstacle. Obstacle means something which blocks. Okay, so it will block the light here. If I have the screen here, what will happen? Here I will have the light, here I will have the light, but here I will have shadow. Okay, so what's interference? What is diffraction here? Diffraction is some part, this shadow is not perfect. The shadow is not perfect. Yeah, means not it's not very dark up to here. Somewhat it is light, some light here also. Okay, so some light bends from the obstacle, some light bends from the obstacle and enters into the region of shadow, enters into the region of shadow. So that phenomena, that changing the path of light, okay, that is diffraction. Did you understand? So what's this? It is the diffraction is what we can say, it is bending of light. It is bending of light. Not only just bend, to prove it, what we are saying, and enters into the region of shadow, so that we can practically see this. Okay, so it is a bending of light, okay, which we call diffraction. And how is the pattern here? To explain the pattern, I will tell you. I can put this slit in another type. For example, if I have ordinary light source and I put two slits like this, okay, it means this is the screen. Okay, so the light will come and pass from this region. So here we are having light, and here we will have shadow, here we will have shadow. Okay, so you can see a little bit clear. Okay, here, because the slit width is very high. Okay, if I make it small, we can apply this concept here also. Here what will happen, it will not be perfect shadow, it will be moving like this. So light will be up to here. Okay, so we can say light is bending. Okay, it does not bend like this, it bends directly. Okay, but intensity decreases. How it happens, we will see completely. So here again the bending of light and entering into the region of shadow, that is called as diffraction. So here what I did, I make it small, very small. Okay, what will happen, here the waves will pass, and what it's looking from here, what we can see from here. So I'll show you the picture how it looks. If you see this screen like this, it will look like this. What is the difference between interference and diffraction here? In interference you have got like this, and in diffraction you have got like this. So the difference is, here you will see the exactly dark and exactly bright bands. Bands means the we can say bangles, like bangles. Okay, so here the dark means perfect dark, or this bright means perfect bright. Okay, here first there will be maximum, after that there will be minimum, after that there will be less minimum, after that there will be more less minimum. Okay, so in this, in the center, the intensity of brightness is highest. Okay, and as we go radially out, it will decrease in the bands. Okay, so that is the first difference. Okay, second difference, sorry, here we are using, in interference I will make the differentiation here. In interference we are using two source, in diffractions we are using one source. Okay, in in interference we have perfectly light and perfectly dark bands. Second point, what we can write here, in diffraction we don't have perfect light and perfectly bright bands. Okay, as we go out radially from the center, it will decrease. Okay, understand? And the third point is, here you will have in interference we use two sources, and yes, that's the difference. Interference we use two sources, in diffraction we use one source. In interference there are dark means perfect dark and bright means perfect bright, and in diffraction there is no perfection in terms of bands. Okay, so we can make difference if we want, if we are using two sources. So the pattern is formed in interference because of two sources, and here the pattern is formed because of two parts of one source of light. Okay, the difference is like that. Okay, see, here we have two parts of light. Okay, so here what is happening, we are using two parts of light, not two sources of light. The source is one, so like this we can differentiate. Understand? So that's it. So what I told you, what is diffraction and what is interference, and I have given you the basic differentiation between the interference and diffraction. Maybe you have understand what is diffraction. Let I give you an example. For example, we come in the daytime and we see everywhere no need of electric light. Okay, no need of bulb. Why? Because the sunlight is there in the daytime. So what happens, how the brightness comes inside the room, how the brightness comes in all inside the room? What is the reason? Because, for example, this is some part, sun is here. Okay, if the sunlight is going, it will go up to here, only up to here or outside. Okay, it cannot go inside, but it goes. We see, if we come here, we see that there is brightness. No need to switch on the electric light. Why? Because light diffracts and go inside every room. Okay, we don't even need to turn on the light. So this is the practical example of diffraction. What is diffraction? Let I revise you once again. It is the bending of light. From where? From an obstacle. For the sun, this is obstacle. For the source, this slit is obstacle. This slit is obstacle. Okay, because it's blocking. The diffraction example is, definition is, the bending of light from the obstacle, from the edges of the obstacle. The bending of light from the edges of the obstacle. Okay, in which the light will enter into the region of shadow. This is called as diffraction. So that's it. I will continue it. I'm gonna rub off this. Deep, I would like to tell you some basic that you must know. So we are diffracting the light by using convex lens, and this is convex lens. Here you should know four things. First, there will be a point that is exactly in the middle of the lens, that is M, midpoint. According to this surface, there will be a center of curvature, C. If I do like this is somewhat like arc, so it must be of some circle. Here you will be having some center, so that it can form circle like this. So this center is nothing but the center of curvature. Okay, it depends. If it is here, curvature is like this. If it is if the curvature is more deep, center will be here, more here, more here, more here, more, yani means light. We are doing the curvature light and hard, light and hard. So this is center of curvature. There will be some point, that is F. What is this called? It's focal point. What is this focal point? If I do according to this surface again, we are studying the focal point. Actually, it's not happened what I am telling you. If the light comes, how it is reflecting? The light is reflecting back through the same point. This point is called as focal point. And this line joining the center of curvature, focal length and midpoint is called principal axis. Principal axis. You should know these basic things. Understand? Now I will tell you how the diffraction takes place. We will use a plane wavefront. You know about the wavefront. Wavefront is somewhat like this, and this is the light ray. How it can be it can be very straight, but sir, we have studied point source, so wavefront will be like this. Yes, but usually we use the light from long distance, so this curves at this point from here to here, it looks straight, that's why we take it straight. So this wavefront will be a straight wavefront. Or if you use the sunlight to do your experiment, then how will you take your wavefront? It will must be straight, because from the sun earth is very far. So the curvature is like that coming from the earth, and how much we are? Nothing in front of sun. So we must be having the plane wavefront. From the big curvature, if you take a small part, how it looks like? It will be look as straight. So this straight things are plane wavefront of the light. This is also a basic. And this wavefront we will use, there will be so many rays, and we will insert or incident on convex lens. And how the reflection takes place, I will tell you. Somewhat here will be the screen. So diffraction will be taken. It will be happen like this. There is point P naught. Like this, the diffraction will take place. More deep, we will look after what I want to tell you now. Okay. Now, I am going to tell you there are two types of diffraction. What is diffraction? Revise once again. It is the bending of light from the edges of the obstacle which enters into the region of shadow. In diffraction, we have two types. Fraunhofer diffraction and Fresnel diffraction. Fraunhofer diffraction and Fresnel diffraction. How you give the instrument, how you keep the instrument on optical bench, that is nothing but the difference. Okay, in both the case diffraction will produce, but what the difference we have when we will call it Fraunhofer and when we will call it Fresnel, when the source of light and the screen have infinite distance. When the source of light and screen have infinite distance, we will call it Fraunhofer diffraction. Understand? In this, we will use plane wavefront. I'm not writing here. Why? Because I want to make you understand. We will use plane wavefront here. And what is the difference? Here, between the source of light and screen, there will be finite distance. And there will be diffraction produced. Somewhere here, we will put the lens. Here, we are using some other type of wavefront, that is cylindrical wavefront. Somewhat like this. Nice. And here, basically, we will use the lens. Here, there is not mention about lens. Not mentioned. Okay. So, three basic things which differentiate the Fraunhofer diffraction and Fresnel diffraction. One, in Fraunhofer diffraction, the distance between source and screen will be infinite. We will use the plane wavefront and we will use the convex lens. In Fresnel diffraction, we will use convex lens or no problem. We can use any obstacle. There will be a cylindrical wavefront and there will be finite distance between source of light and we are discussing the diffraction. So I told you somewhat this is like diffraction. All are the rings. This is suppose something like diffraction, and now I will tell you, if I take what I told you, in between, in the center there will be point of maximum intensity, brightness is maximum. After that there will be a dark ring. After that there will be again a ring of brightness. Again there will be a ring of darkness. Again there will be a ring of small brightness. Again there will be a ring of small darkness, like that. Okay. This is light diffraction. So in center there is a brightest point. I am telling you because if you know before, you can understand better. If we draw the graph between intensity and the path difference or wavelength of the light. what we can see? We can see in the center, here, the intensity is maximum. As we go away, here intensity is maximum. As we go away, there is darkness. There is darkness means intensity decreased. There is both the side. If we talk about first side first, then we will see the second side. Here the intensity is maximum and here it is decreasing. There is the dark ring. After that, again there is a ring of brightness. Again the intensity will increase, but not more than this. Again it will come to maximum, again it will decrease. It will continue like this. On the other side, same. Let's study this graph. What is this actually? This is the biggest band or biggest ring width. Okay, width, I'm talking about the width. Here the intensity is maximum. So this is central bright point. What we will call it? Central bright point. This is central bright point. Now the counting will start from secondary. Secondary, remember it. This is maximum. Start from here. Start from here. Both the side. We have minimum intensity. We have minimum intensity. So what minimum intensity? It is secondary minimum. We will call it. Okay. This is central bright point. What is this? Start from second. Start from the second. This is secondary maximum. Again here, what is it? It is secondary minimum. Understand? It is secondary maximum. Understand? Maximum, minimum. Understand? You should remember this, because while I will explain the diffraction, you should imagine what I am talking about. Now let us start. This is the lens. This is point A. This is point B. I am using plane wavefront. The waves are coming like this. This is point C. Now here I have the screen. The light will diffract. How it diffract? Look. Before that, how the light come? Light is coming across the slit. What is this slit? There is a gap. The width of this slit gap is A. Remember always. Remember what I am telling you. Here it's coming in the center. On the screen, how it will look? Like this. What will be the intensity and path difference relation? Like this. Now we have this point P. We will have again point of secondary minimum here, again maximum, again minimum, again maximum. Maximum I am not drawing. I draw only for the brightest point, that is P. So what are these? These are minimum. These are minimum. So here will be another point. I take a little gap to make you see better. This is again secondary minimum, this one. This is secondary minimum, this one. Again it will go, it will continue. This is brightest point, that is P0, brightest point. And this is the point, that is point of secondary minimum. So here the rays will come like this. So did you understand the diagram? Nothing is there. We have used one slit. We have used, as we discussed before, we have used plane wavefront, a lens and a finite distance, and the width of the slit is A. There are 3 points A, B, C, and there is the brightest point on the screen P0, and there is point of secondary minimum and the distance between them is x. Here if I draw, it will be again x. Here this is this. So width of the central bright point will be 2x. That we will see later. Now what happens when the diffraction takes place? The secondary waves are reaching at point P. Why? Because there is path difference. Total path difference is how much? Total path difference is lambda. Total path difference is lambda. So we have divided this whole light into two parts, AC part and BC part. Did you understand? AC part and BC part, these two. Now if I take the perpendicular on this secondary wave, so I should take like this. Here will be some theta, here will be 90. If this is 90, this must be, AB must be hypotenuse. So what is the path difference? I will write the name of this point where I have taken the perpendicular, that is E. This BE is the path difference. This is the difference of the path. Because of this, it is diffracted to the secondary minimum. Now if I apply sine theta here, this is theta, okay. So sine theta will be opposite upon hypotenuse. What is opposite? BE. And what is hypotenuse? AB. Understand? So BE will be equal to AB sine theta. Is that correct? AB comes here. What is AB? This is nothing but the width of the slit. That is A sine theta. What is this BE? This BE is the path difference that we are going to denote by lambda, because it directly relates with the color. Color depends on the wavelength. That's why I have written lambda. So it will be n multiple of lambda. Now we will talk about this. We got this equation. Remember this. A sin theta equal to n lambda. Now A sin theta is equal to n lambda. We got this equation, and this is the equation for path difference. So what is the path difference? Suddenly you should no, frequently, or no, what should I use? Quickly. Yes, quickly we should you should remember lambda. Another thing, A sin theta. Another thing, A sin theta. So this is the path difference. Now why we get this P naught and why we get this P? Now I am going to discuss the location or position of the central bright point and secondary minimum. Understand? So first we will discuss the position of secondary minimum. Why it is here? Now you tell me, this is half of the light, AC part. This is half of the light, CB part. If the path difference is lambda, we are getting P naught. Path difference is lambda by 2, then we will get lambda by 2 plus lambda by 2, that is P naught. What is the path difference for P? That is position. We are discussing the position of secondary minimum. Position of secondary minimum. That's why I show you minimum. That's why I have shown you before this. If I say directly secondary minimum, so you will get confused. So we are discussing position of secondary minimum. Why it's here? Now let us see, if you want to have the minimums, what is the thing you need to understand. Here the wavelength, the secondary waves are coming from half part AC and half part CB that have the part difference of lambda by 2 and lambda by 2. Understand? Lambda by 2 plus lambda by 2, how much it is? 1 lambda. And if the part difference is lambda, then you can say there will be a point of minimum intensity. First, secondary minimum. First, secondary minimum. Why? Because lambda by 2 plus lambda by 2, lambda. That's why we get only lambda. How much? N multiples of. So I'm gonna write here. This is sine theta. If I discuss, it will be minus lambda. You can put minus lambda by A if you are getting the relation between intensity and theta. Minus 2 lambda by A minus 3 lambda by A. Here lambda by A, lambda by 2 lambda by A, 3 lambda by A. That is the scale. You know this. Now here it's minimum n multiple of lambda. So where will be the position? The position will be whenever there will be a sine theta equals to n lambda, where n is equals to plus or minus 1, plus or minus 2, plus or minus 3. It means integral multiple of, or integer multiple of, when the path difference will be integer multiple of integer multiple, okay, then we will get secondary minimum. Did you understand that? Okay, simple. No, just I am not writing the theory part. I am explaining, but I am not writing. Okay, so what you are going to write here? You know, construction and working. You have taken a slit. The width is A, the length, the points ABC. They are diffracting, and we are getting the points P0, the point P0, which is the brightest point, and point P, which is again a point P of minimum intensity. Okay, the distance between P0 and P is X. The part difference is BE. If we take the perpendicular on BP, if we take the perpendicular where I have taken on BP, then you will have another point E, and if you apply the sine theta, it will be like this. And I told you what is the definition of path difference. What is path difference? Directly say A sine theta. Okay, so whenever there will be n multiple of lambda, you will get the position of secondary minimum. If there is a question, start from here for secondary minimum, no problem. Now I will tell you the position for of secondary maximum. Now look at this maximum. Where is the position for secondary maximum? Here. Okay. Here, what they are having, we will take A sine theta is equals to odd, here integer multiple, here odd half multiple of lambda, So in physics we know what is odd. What is odd? Odd is twice n plus 1, because this is the formula for odd number. Twice n plus 1, simple. Put n equals to 0, twice n plus 1, 1. Put n equals to 1, twice n plus 1, 3. Put n equals to 2, twice n plus 1, 5. 1, 3, 5, 7, 9. What you are getting? Odd number. So I can write tau is n plus 1 lambda, I write y2 here, that is equals to a sin theta. So whenever there will be a question, you must say what is the position for secondary minimum. Sir, secondary minimum is there when a sin theta will be equal to some odd half multiple of lambda. What is lambda? Wavelength of the given light. Simple. Okay, so this much you have understand. We have seen today what is diffraction, what is diffraction pattern, what are secondary minimum, what are secondary maximum. This is nothing but the start of counting in diffraction pattern, and how the diffraction takes place and what is the explanation behind that. I hope you understand. I will meet you in the next video.